Good day, I am Stella Anmaris A. Montesinas, together with my group members, Ragay Lady Liberty and Flores Naomi Janelle. Let me introduce first our project entitled A Machine Learning-Based Diabetes Health Companion for Risk Prediction and Glucose Trend Forecasting with Explainable Health Insights. So, Diabetes is an AI-powered health companion that predicts diabetes risks and future glucose trends, while also providing clear personal insights to help users make smarter health decisions, improve daily management, and prevent complications before they happen. Now, let's first discuss what is cloud computing before we introduce to you on how we deploy our project. So cloud computing means using computing resources through the internet. So instead of relying on the storage in our local computers, cloud computing uses servers, storage, databases, networking, and applications. So for diabetic, cloud computing is important because it allows the system to be accessed online through a browser. So our project was deployed in the AWS EC2, and later on, Ms. Karagay will show you or demonstrate to you on how we deploy the project. So instead of running only on our laptop, on our site as a developer, the system now can run on a cloud server and become available to all the users through a live URL. Since I mentioned to you that our project was deployed in the AWS EC2, let us know what is this platform means. So it is a service from the Amazon Web Services that provides a virtual server in the cloud. So this virtual server works like a computer that can run applications online. So in our project, we use an Ubuntu EC2 instance to host the Diabetes. So this server runs on the Flask backend and the MySQL database using Unicorn, Nix, and other system dependencies needed for this deployment. So what is the advantages that we use cloud computing to deploy the project rather than to run the application in our local device? So cloud deployment makes the system more accessible because as the developers, it is not appropriate that we share our own devices. So if we want it to make accessible for other users, so they can use their own devices to run the application through a live URL with the means of deploying it in the cloud. So for Diabetic, it is useful because the system needs online access for login, health tracking, dashboard viewing, report sharing, push notifications, and PWA features. It also prepares the system for future improvements such as backup, scaling, and better monitoring, which is the advantages in the AWS EC2. So in comparison, in the local hosting, it means that the system runs only on one computer, usually through a local host. But this is useful during the development and testing. But it hinders the access for other users because it is a limitation because other users cannot easily open the system from different devices or across different locations. But with the help of cloud hosting, it is now different because the system runs on an online server. In our case, Diabetic, like what I mentioned earlier, it is deployed in the AWS EC2. So it is now accessible through a live URL that makes cloud hosting more suitable for systems that need online access, shared data, and real user interaction across the world. Now, for the EC2 demonstration, here is Ms. Karagay Lady Liberty.
Good day. Today, I will demonstrate the deployment and functionality of our system Diabetic. This demo will cover the AWS Management Console, EC2 instance configuration, security group, deployment process, running application on EC2, and the actual system features. I will also show that the user can access the deployed application through a browser. First is this is the AWS Management Console. This is where we manage the cloud services used for the deployment of the AWS. For our project, we use the Amazon EC2 server, which provide a virtual server where we can host our applications. Here we can see our EC2 instance. The instance state is running, which means that the server is active and ready to serve the applications. This instance is the main server used to run the diabetes. The public IP address is used to access the deployment application and also connect to the server through SSH. Now, we're going to explain the detailed stuff of EC2 instance. For the EC2 instance configuration, we use an Ubuntu server. Ubuntu was selected because it supports the tool needed for our project such as Python, plus MySQL, Unicorn, and other deployment packages. The instant type uh, defines the computing resources of the server such as the CPU, memory, storage, and the storage is used for the applications file is MySQL database, logs, and backup files. We also configure a key pair during instance setup. The key pair is used to secure the SSH access to the Ubuntu server. This allowed the developer to manage the server from the terminal. The EC2 server as the cloud services where Diabetes is deployed and running. This part shows the security group of the EC2 instance. A security group works like a virtual firewall. It controls which traffic is allowed to enter the server. For example, SSH is used by the developer to connect to the server through the terminal. HTTPS is used so user can access the diabetes system a through a browser. This is important because not all ports should be open. Only the necessary ports should be allowed. This protects the server from unnecessary or unauthorized access. So in our deployment, the security group controls the basic networking access from the system. Now I will show the deployment process of EC2 in our terminal. First is we need to connect the EC2 through our terminal. We connect to the EC2 using the SSH. This SSH allow the user to access our website securely and manage the Ubuntu server through the terminal. Inside the server, the project files are stored in the diabetes folder. This contains the plus application files, template, static files, route model, configuration files, and other system components. Then this CD diabetes ls, this file represents the deploy project inside the EC2 server. This means the project is no longer running locally. It is already placed and configured inside the cloud server. To keep the application running, we use a service named Diabetes. This service allows the application to run in the background even if the terminal is closed. Here the status shows active and running. This means that the Diabetes application is currently running on the EC2 server. If we need to apply some update or restart the application, we can use the systemctl restart command. This command restart the application service update after update or changes. Next command is the journal CTL. This journal CTL show the recent logs of the diabetes service. Logs are useful for checking if the application is running properly or if there are errors during the deployment. In a real deployment process, log helps us troubleshoot problems such as database connection error, email service error, or application crashes. The database is this database used by the system in MySQL, and it is installed inside the EC2 Ubuntu server. That is why the live database is accessed through the terminal, not directly from the AWS console. Here we can see the database name diabetes.tv. This database stores important system records such as user profile, tracking entries, OTP records, and other applications. I will only show the database and table for demonstration purposes since it involves sensitive data such as password, API keys, or private records will not be shown. We also configured a weekly database backup. This is done using cron. This cron is the scheduler in Ubuntu. It automatically runs the backup script every week. The backup export the MySQL database and save it as a compressed file. Here we can see the backup folder where the database backup files are stored. This help provides a recovery option in case there is a database or server issue. We also tested the backup restore so we know that the backup file is usable and not only created. For security, we also check the API key and secret key handling. Sensitive values such as Bravo API key, database credential, and secret keys are not supposed to be hard-coded in public files. The system uses environment variable for configurations. This means that the application can read the needed values from the server environment without exposing them directly in the code. We also check and clean the documentation files to avoid exposing real keys. Now I will open the deploy diabetes application through the browser. This shows that the system is accessible online through the EC2 server. This proves that the user can access the application through a browser as long as the server is running and the required ports are allowed by the security groups.
Now that you already watch how it is demonstrated in the AWS EC2, let me have the floor to introduce to you our system.
So for the system demo, we prefer to demonstrate it to you using a mobile phone since this project is a progressive web application that acts like a native mobile application. So let me click the app. There is a security notice that the user needs to have one-time password using the OTP every 15 days to secure their account. So they can also sign up for free and select account type based on what they need. We also have the forgot password when the users forgot their passwords. Then we can resend it again. So now that we received a new code, let's input it again. Now we can enter new password. It also has a strong implementation requiring users to have a strong password. Now let's sign up. So after logging in, there is a data privacy notice to notify the users on how the app collects and processes information that they give to support the health monitoring experience. So this is the dashboard with a manual for users to know how the model works and how each result is produced, how inputs are evaluated, and how often it updates. So our system operates in online and offline with auto sync. There is also a notification bar here for the push notification. We also add here a logging script so that the users will love to continue on logging in their entries. So here are the cards or the summary risk score for the diabetes risk, the predicted next glucose, and the average 7-day glucose, and as well as the activity. Here are the top contributing factors that can also be seen in the dashboard, as well as the quick status and the recent glucose readings. Here is the track page that the users could use to log their glucose, meals, activity, and sleep with a clean and responsive interface. Now for the analytics. So these are the charts that could guide users to understand how each life factors affect on their diabetes health. We have here the correlation between the behavior and glucose in terms of sleep, activity, and glucose readings. We also have here the risk factor impact that serves as our explainable AI. So the text here is easy to comprehend so that the users will really understand how these factors matter. Here are the correlation insights between activity, glucose, sleep, glucose, diet score, and glucose. We also have here the weekly summary and the monthly summary. Now in the recommendations, all of the recommendations here are personalized through a rule-based, and this rule-based guidance is aligned with the guidelines from the WHO or the World Health Organization. So these are just prevention guidelines with their track habits, and this is more on the educational purposes and not a medical diagnosis. So for the user profile, these are the biomarkers when the users log in first, so they are asked to fill out this form. So we also have here instructions that the data entered here helps to improve the model predictions for the risks in diabetes and recommendations. In the reports, so we have here the medical disclaimer so that the users will always be reminded that diabetes is only for lifestyle monitoring and diabetes risk awareness, health tracking support, and not a medical diagnosis. So we added this kind of feature so when a user has a doctor, the logs or the entry logs that she or he had here can be shared organizedly and through a PDF. We can export it as PDF. All the history of glucose, meals, activity, and sleep. So this is in a pagination so that it enhances user experience without needing to scroll a long history. So that will be all for the user side. So I'm going to log out. So let's try to log in as an admin using a mobile phone. So we restrict the admin to use a desktop since the role is more on the protection and security, so using a mobile phone is not necessary. Here, the admin has an overview of the total users, profiles complete, active logouts, and the total log entries. We also have here the account health, the recent user accounts, and the security controls that is implemented in the system, like the password hashing, OTP verification, login lockouts, field encryption, CSRF protection, admin only access. So it is also visible here on how the model works, how it was trained, and what certain model was used. So at this part, in the admin, we can also see some information on how the risk classification and glucose trend work. Then we have here the recent health events, the data inventory for the glucose entries, meal entries, activity entries, sleep entries. And at the bottom, we have the system health for the database, email API, and also the model runtime. So as you can see here in the admin, it is simple since it is more focused on implementing security. So let's go to the user management where all users in the system is stored here. Then we also implement pagination. Now, the most important part or the feature in our admin is the login audit. So this is important, especially in the field of information security and information assurance. So this is audit records that serve as a log. So whenever there is a data breach or attack, so these records are helpful to track what activity or what endpoint has been leaked. It can be filtered through success, warning, error, info, and all status. So that's it in the admin. So I also want to show you quickly on how it renders or display here in the laptop for the user side. So same here, we have data privacy notice. So I won't be explaining, instead I will be touring you in the user side since I already explained this earlier in the mobile view. So let's appreciate how it looks here in a laptop or a desktop mode.
For the last part, let me have the concluding section by Miss Flores Naomi Ginalgi.
To conclude the presentation, we've encountered challenges during the deployment, such as the server configuration and the system setup, especially the SSH connection, the security group rules, internal server errors, and database setup because we have to from localhost to cloud. It was difficult to transfer from localhost to cloud. If because of also the environment variables, the email API configuration, the push notifications of application, and the service worker cache, the links and unicorn, which are a part of tools for the diabetes to run on the cloud. Also, that these challenges help us understand that cloud deployment is not just about uploading the project online and letting users use it. It also requires proper knowledge on how to configure, debug, do log checking, security setup, and continuous monitoring na dapat na nagme-make sure na yung system is magwo-work properly during the deployment and when users use it. So during the deployment ng system is we learned that yung Plus project can be from a local project, it can be an online web application that can be used by many users. we learned how AWS EC2, Ubuntu, MySQL, Unicorn, Nix, HTTPS, um, those systems on platforms work together to build a running to build and run a deployed system. So we also learned that yung pag-check ng server logs kasi dun mo makikita yung mga errors and also mas madali siyang i-identify kung ano yung mga missing packages, bakit nag-error, sang part ng code ng error, sang part ng file nag-error, anong file yung may error. So, dahil doon, na-figure out ng mabilis or mabilis na papatch yung mga errors na yun because of the server logs. And then next, yung stand ng cloud computing in terms of the information technology sector is that important siya kasi siya yung nag-help para ang isang application or ang isang system is ma-reach yung mga target users nila and magkaroon yung mga developers ng way para mabilis ma-deploy yung project and applications na ginagawa ng mga developers. Also, ayun nga, lagi binabanggit, it allows users na magamit yon easily without one local computer. Kasi nga, accessible siya anywhere. Also, sinusupport niya kasi ang scalability, centralized data management, tapos yung backup planning, yung mga redundancy ng data, and then yung security niya at saka system reliability kasi yung availability ng system and data, ginagamit natin. Tapos, pinaka-important na help sa developers at saka ng organizations ng cloud computing is that mas madaling mag-deploy, mag-maintain, at improve ng applications without directly managing physical servers kasi nga cloud yung gamit natin. So, in conclusion, AWS EC2 allowed our system, Diabit, to become a project that is just hosted locally into a cloud-based web application that can be used by users. And also, nakahelp siya na mag-show na paano ba gumagana ang isang real-time at saka real-world health monitoring platform. So, use ng Diabit ang cloud hosting para masupport ang health tracking, diabetes risk awareness, glucose forecasting reports, and notifications sa isang user. Overall, yung pagde-deploy ng project is naka-help kung paano gumagana talaga ang cloud computing and how does it support the IT systems at bakit siya important sa mga applications na ginagamit natin ngayong century na to. And bakit online na tayo.
That will be all. I hope you watch and enjoy this video to learn more about the diabetes. Thank you.